Discovery of atomic nucleus and neutrons. In this lesson, we shall learn about atomic nucleus and neutrons. In 1909, Ernest Rutherford tested Thomson's hypothesis by his gold foil experiment. In 1909, Ernest Rutherford tested Thomson's hypothesis by his gold foil experiment. He directed alpha particles from radioactive source. Alpha particles are positively charged helium atoms having 2 protons and 2 neutrons. Rutherford observed that most of the alpha particles went straight through the foil. However, some particles got deflected slightly. Apart from these two types of particles, only a few particles were deflected to a greater angle, or when bounced by 360 degrees. When the thickness of the gold foil is doubled, the number of alpha particles reflecting after striking also becomes double. From the above observations, Rutherford concluded that an atom is relatively empty. It is because of the empty space that the alpha particles were able to pass straight. Rutherford's deflection was not in par with Thomson's model. He stated that some particles got deflected slightly because of the presence of small and concentrated central mass. The alpha particles that hit the concentrated positive mass get deflected through large angles. The postulates of Rutherford's atomic model can be summarized as: matter in an atom is located in a small central part called nucleus. The remaining part of the atom is empty. The nucleus contains the positive charge of the atom. In an atom, electrons revolve around the nucleus. An atom is neutral. So to attain stability, an atom must have sufficient electrons to counterbalance the positive charge. Rutherford calculated that the radius of the atom is 1 upon 10 to the power 8 centimeter, and the radius, the nucleus, is 1 upon 10 to the power 13 centimeter. But Rutherford's atomic model could not explain the stability of an atom. According to Rutherford's atomic model, the electrons revolve around the nucleus, and the attracting force of the nucleus is balanced by the centrifugal force due to the rotation of electrons. According to the electromagnetic theory, an accelerating charged particle must emit radiation and lose energy. So due to loss of energy, an electron would slow down. As a result, the electron should initially follow a circular path and then ultimately fall into nucleus. If it happens, then the atom should collapse. But this does not happen. The second drawback is that the Rutherford's model of atom does not say anything about the arrangement of electrons in an atom. Rutherford stated that the element helium, after hydrogen, has 2 protons. So ideally, the mass of helium should be double of hydrogen. But it was found to be about 4 times of hydrogen atom. It was also known that electrons have negligible mass. Hence, the mass of the atom is concentrated in the nucleus. So scientists predicted the existence of particles that have mass almost equal to that of proton. James Chadwick in 1932, while doing a research on radioactivity, discovered this particle called neutron. They were found to be as heavy as the protons. Neutrons and protons together, called nucleons, are bound together in the nucleus. The total number of protons and neutrons in an atom is called atomic mass.